We're working through an example of solving compound inequalities, so keep it here. I'm Allison from Math Bytes, and we're doing an example of solving compound inequalities. So here's our first problem. We have 2x minus 7 is less than or equal to 13, or 3x minus 1 is less than or equal to 5. All right, so we're going to solve both of these inequalities and then come up with our solution set. Let's just take one at a time. Let's start with 2x minus 7 is less than or equal to 13. I'm going to add 7 to both sides. So I get 2x minus 7 plus 7 is less than or equal to 13 plus 7. That leaves me with 2x is less than or equal to 20. And then multiplying both sides by 1/2 to get rid of that 2 in front of my x, I get that x is less than or equal to 10. Okay, now let's do our other inequality. 3x minus 1 is less than or equal to 5. I'll add 1 to both sides. So I have 3x minus 1 plus 1 is less than or equal to 5 plus 1. And that leaves me 3x is less than or equal to 6. Multiplying both sides by 1/3 to get rid of that 3 in front of my x, I get that x is less than or equal to 2. Okay, so we have a solution for each inequality, but it's a compound inequality. We have this or that. So here's something to remember. When you have an or inequality, you take the union of your solution sets. So let's draw our solution sets on a number line. Let's start with x is less than or equal to 2. So on a number line, that would include 2 and then be everything less than it. Okay, so now let's draw x is less than or equal to 10. So again, that would include 10 because it's less than or equal to, and it would be everything less than or equal to 10, so everything below 10 as well. Now, what's the union of those two sets? Well, x less than or equal to 2 is included in x less than or equal to 10. So the union of both of those solution sets is just x is less than or equal to 10. So the solution to this compound inequality is all x, such that x is less than or equal to 10. Okay, here's our second example. We have x plus 3 is greater than 5, and 2x plus 1 is greater than 17. So again, let's just do one inequality at a time. So I have x plus 3 minus 3 is greater than 5 minus 3, which leaves me with x is greater than 2. And 2x plus 1 minus 1 is greater than 17 minus 1. That leaves me with 2x is greater than 16. Multiplying both sides by 1/2 to get rid of that 2 in front of my x, I get that x is greater than 8. All right, now the solution set for an and compound inequality is the intersection of the solution sets for each individual inequality. So now we have to take the intersection of x greater than 2 and x greater than 8. So again, let's draw these on a number line. Let's start with x greater than 2. So on our number line, we won't include 2 because it's strictly greater than, so it's just everything greater than 2. Now let's draw x greater than 8 on our number line. Again, we don't include 8 because it's strictly greater than, and it's just simply everything greater than 8. So the intersection of those two solution sets is x greater than 8. So the solution set to our compound inequality is all x, such that x is greater than 8. So remember, when solving compound inequalities, for an or inequality, take the union of your solution sets. And for an and inequality, take the intersection of your solution sets. To learn more about this topic, watch our videos on the Math Bytes with Allison YouTube channel.